Before moving on to concrete examples, I want to explicitly mention one more design dimension when it comes to distributed file systems. We said that the client and the server can be distributed to different machines, but the file server itself can also be distributed. This can be achieved via replication or partitioning. With replication, the file system can be replicated onto multiple machines such that every single machine holds an exact replica of all of the files in the system. The benefit of this can be that the client request can be load balanced across all replicas, across all machines, and this can lead to better performance. The system overall can be more available. It will return responses more quickly, and also it is more fault tolerant. When one replica fails, the remaining replicas can continue serving the data for all the files. The downside is that now the write operations that update the file system state may become more complex. Not only do we have to worry about the consistency among the clients that may cache the file and the servers, but also about the consistency among all of the replicas. A simple solution is to force every single write to each replica, and only after that is done to actually return to the client and to consider that the write operation has completed. This will slow down all writes. An alternative would be to allow the writes to be applied to one server, to a single replica copy, and then to have some background process that asynchronously propagates these writes to the other replicas. If it turns out that there are any differences among the state of a file on different replicas, then these differences need to be resolved. For instance, we can use a simple technique like voting, where the votes are taken from all servers and majority wins. There are many other techniques how these sorts of issues can be resolved, but these are beyond the scope of this course. The other technique is to distribute the file system state using partitioning. As the name suggests, in partitioning, every single machine has only a portion of the state, only a subset of all of the files in the system. This may be done based on file names. For instance, all the files from A to M sit on one machine, and all the files from N to Z sit on another machine. Or we may choose a policy where different directories are stored on different machines, where we somehow partition the hierarchical namespace of the directory tree structure. There can be various criteria that can be used to decide how to partition all the state in the file system. Using this technique, we can definitely achieve greater availability compared to a single server design. Each server here will hold fewer files and therefore will be able to respond to a request for those files more quickly, so it will appear to be much more available. The most important benefit of this design is that it provides for greater scalability when we consider the size of the file system, the overall size of all of the files stored in that file system. With replication, given that every server has to hold all the files, the size of the file system will be limited by the capacity of a single machine. In partitioning, if we need the bigger file system, we just add more machines and problem solve. And finally, unlike in the replication case, in the partitioning case, when we need to perform a write to a single file, that will remain localized to a single machine. So that's much simpler than what we have here. One of the main problems with this approach is that when there is a failure, a portion of the data in this file system will be lost. So all of the files that are stored on that particular machine, the machine that failed, will not be accessible anymore. In addition, balancing the system is more difficult because we have to take into consideration how the specific files are accessed. If there is a particular file that's more frequently accessed by most clients in the systems, then that will create hotspots. Finally, these two techniques can be combined to have a solution where the files are partitioned across different groups or in different volumes, and each of these groups is then replicated, potentially with different degree of replication. For instance, you can have partitions of read-only files versus files that are also written to, and you can replicate the read-only files to a greater degree. Or you can consider having smaller partitions where there are files that are more frequently accessed versus larger partitions that consist of more files but less frequently accessed files. And then you can consider using different degrees of replication for the partition that has more frequently accessed files versus less frequently accessed files, so that overall each machine has approximately the same number of expected client requests.